Welcome back to the Learning Studio. You're watching our mathematics series where we uncover the foundations of science, technology, and artificial intelligence. If you're new here, make sure to follow us by clicking the link below. And remember, the complete playlist is also added in the description, so you can catch up on every episode in order. Last time, we explored probability theory, the mathematics of uncertainty. Today, we take the next step with statistics, the art of turning raw data into meaningful knowledge. Let me give you a real-world example. Imagine you're a scientist testing a new medicine. You give it to 1,000 patients. Some get better, some don't. Now here's the big question. Does the medicine actually work, or is it just chance? This is where statistics comes in. It allows us to take messy, real-world data and draw conclusions with confidence. In fact, statistics is the bridge between probability theory and real-world decision-making. Without it, we'd be lost in numbers, unable to separate truth from noise. Core concepts simply. Let's break it down. Estimation. With data, we often can't know the exact truth, like the average height of every human in the world. Instead, we take a sample and estimate. Statistics helps us make those estimates as accurate as possible. Hypothesis testing. Remember the medicine example? Hypothesis testing asks, is the observed effect real, or could it have happened by chance? This is the backbone of scientific research, quality control, and even A/B testing in tech companies. Regression. This is about relationships. For example, how does the number of study hours affect exam scores? Regression helps us model and predict outcomes. In AI, regression techniques form the basis of predictive modeling and supervised learning. Bayesian inference. This is where probability and statistics shake hands. Bayesian methods update our beliefs as new data arrives. Imagine a spam filter. Each time you mark an email as spam, the system becomes more confident in predicting the next one. That's Bayesian statistics in action. Why statistics matters in AI and real life. From medicine to marketing, from climate science to machine learning, statistics is everywhere. AI models themselves are statistical at their core. They learn patterns from data, make predictions, and update over time. Even the recommendation system that suggested this video to you is built on statistical foundations. Simply put, statistics is the science of learning from data, and in the 21st century, the age of big data, it is more important than ever. So the next time you see numbers in a survey, results in an experiment, or predictions from an AI model, remember, it's statistics that gives those numbers meaning. In our next episode, we'll dive into numerical analysis. We'll discover how mathematicians and computers work together to approximate solutions, analyze errors, and solve equations that are too complex to tackle by hand. This is the mathematics that powers simulations, scientific computing, and even engineering design. Don't forget to follow us by clicking the link below and check out the full playlist in the description. We're building the foundation step by step, and the best is yet to come.